Welcome to Insight Builder channel, large language model automators, Python experts, and my dear friends. DSPy modules. What can you tell me about DSPy module? Before we dive into the discussion about DSPy modules, I believe that you have seen my earlier videos on DSPy signatures, DSPy large language model connectivity processes, and also DSPy overarching basic video. Modules are a little bit advanced. If you are having a bit of a Python programming and object-oriented coding knowledge, it will be way easier to understand this video. If not, I would suggest you to directly look at the code walkthrough in this series of chapters and directly go there, because initially I'll be discussing about how these modules, the DSPy modules, are implemented as Python classes inside the DSPy. It's going to be a little bit of discussion on the classes, how the prompts are written inside those classes. I'll be showing you the code also. The code is also present inside the DSPy API documentation. I've just copied it and pasted it here, but it is pasted in this particular notebook. So all you need to do is scroll it down and you will be finding it. Keeping everything in one place is much more easier to control and learn. So that's one of the point. You don't need to jump between multiple pages. That feels, that breaks the flow. So that's the reason why I'm, making this very large, huge Jupyter notebook. Even the earlier videos that I've made in DSPy, the examples, the code walkthrough can be found in the same notebook. Yeah, it's pretty long. Moving forward. Why modules? Modules are Python classes and they abstract prompting techniques. Yes, that's very important. Why modules? They abstract prompting techniques. Second, they contain learnable parameters. Every module that is inside DSPy have different kinds of parameters that you can pass. These parameters can be modified during the compile time. This kinds of modification in the compile time is called as learning. And this concept of learning comes from PyTorch library and large language model concepts, fine-tuning and learning in large language models. But the learning in large language models, the updating of model weights in large language models is called as fine-tuning, while what you do in DSPy is called as compiling. It's kind of a learning process, but it's not the same as updating the language model weights. So there it is purely mathematics. Here it's partly mathematics and also it has kind of a human touch to it. I will explain these things in the next couple of videos after completing the introduction to data and metrics. After that only we will go to optimizers, where we will look at how the optimizers change or modify these model parameters. So stay tuned till then. It can be combined to build complex modules. So this is like, you can take one module, for that matter predict, and you can combine it with ChainOfThought, you can combine it with retrieve. So these are all various modules that I'll be introducing in a couple of minutes. And finally, some modules emit additional information that you can use it for your benefit. How to create these modules? There are two ways. You can create the objects with single module, or you can chain them into complex modules. You'll be seeing the examples down, so I don't want to dive into that right now. And these are the various modules. You have predict, you have ChainOfThought, you have ProgramOfThought, React, MultichainComparison, retrieve, and majority. There are lots of, the definition here that is provided is a little bit cryptic. I've just taken the definitions from the DSPy documentation. Let me give a very brief introduction for each of these modules right now. So predict is very similar to how you do a template prompting. In case of template prompting, we have an input that we give it to the language model, and then we expect an output. And this input, we can modify it for each of the prompting that we do. So for the first prompt, you might have input 1. For the second, you might have input 2. Like this, you will do it for multiple times. If you are going to do such a prompting, then you can use predict. And each time the output will be different depending on your input. Second, ChainOfThought. ChainOfThought teaches the large language model to think. So it tells instructs the large language model to think and answer to the prompt that we have provided. It's also having a similar kind of a template where the input is provided and the output is expected. The input can be modified in any way you want. These inputs and outputs are called as signatures. You can take a look at the discussion that I have done on signatures, DSPy signatures. That will actually give you a very deep grounding on how the modules take the signature and start processing it. It's very important. Anyway, we will also discuss the same things in this video also. Signatures and modules are closely linked. Continuing further. ProgramOfThought. ProgramOfThought is very similar to ChainOfThought, but in case of ProgramOfThought, we ask the large language model not just to output code, we also ask the large language model to execute the code. So the model itself executes the code as if it is a Python interpreter. There is no other interpreter or there is no Python interpreter connected to the large language model. Keep this distinction in mind. The model itself executes the code that has been provided by the earlier step. Moving forward, React, the agent that can use tools to implement given signature. React, you can pass the various kinds of functions and tools that you want the model to call, and the React will do the necessary prompting internally to call the functions and then do the processing. And also it can interact with the retrieve object, that is the vector stores. Multi-chain comparison is what it is actually saying. So you can take the prediction from various outputs, various modules, the generations from various modules like predict, ChainOfThought, ProgramOfThought, etc., clean it and then send it to multi-chain comparison and get the comparison that is best from the large language model. It's like ensemble model. We have retrieve. Retrieve is connecting with the vector stores and vector stores through the HTTP service, and then it extracts the context and then gives it to the large language model. So it's more like a vector store retriever. And then we have majority. Majority is like kind of a basic voting setup where the various options or the model predictions are sent to this particular module and it does the voting. It is purely probabilistic. It differs every time, but even with probability you can get a very good output. So in fact, large language model themselves are giving this much output because at the backend there is a algorithm that uses the probability. That's a very brief introduction on the various modules. Next, what you're going to dive into is the module parameters. So I have introduced these various modules, and these various modules have parameters. If you have seen my videos, I usually create these kinds of Python objects, in fact, dictionaries, I call them. And I create them so that it is very easy for us not just to only take notes, but also it is easy for us to use this to create further applications. So whenever you are learning something, if you are going to create notes like this, it's going to be very useful later. So if I execute this particular cell, what will happen is the module params will contain a dictionary, and I can start accessing the dictionary step by step by using these keywords like predict, ChainOfThought, ChainOfThoughWithHint, multi-chain comparison, ProgramOfThought, React, and retrieve. And all these keys that I read right now has its own values, and these values are the parameters. So predict has signature parameter and the config dictionary. This double star config dictionary can be multiple other parameters that cannot be listed here. It's kind of group of parameters which is optional. Next, ChainOfThought has signature, rational type, activated, which is a boolean, and then config dictionary. ChainOfThoughtWithHint, again the same thing, signature, rational type, activated. Multiple chain comparison has signature, this M, which is actually the number of chains, the temperature that tells how the language model should do the generations, and then the config dictionary. ProgramOfThought, it is signatures and maximum iterations. There is no config dictionary here. In case of React, we have signatures, maximum iterations, number of results, and tools. So this is a little bit different. In case of retrieve, it is just the number of documents that we are going to retrieve. It is called as K. That's about the module parameters, and these are the parameters that will get modified when the modules are compiled. Moving forward, first class that we are going to look at is the predict class. The predict class is going to take the input field, output field, and the inferring prefix function. And the predict class is also going to take a parameter class, and it is going to inherit inside itself. And you'll see the point that I wanted you guys to observe is the instruction part. So this instruction, you don't need to worry about what logic is going on here, what is happening in this init. People who know Python object-oriented programming, they will be able to understand that. The point here is this instruction. So the entire class is implemented in such a way that this particular instruction can be coded into this class, and it can be used for all the objects that are created using this class. And all the objects will have this instruction inbuilt into that. And this instruction is the prompt. That's what I want you guys to look at it. And it's very simple, guys. What is happening right now is that instead of writing very complex prompt, you are making the prompt as simple as possible. And this prompt can get modified during the compile time. That we will look at it later when we look at how to use the modules to learn. We will look at that later. But as of now, this is a very simple prompt that is being used. If this prompt doesn't work, then it can be modified. But how to decide that it doesn't work? So for these things, you have to first of all understand the data, how the evaluation works, and how metrics are created on top of evaluation, and how the final output can be measured. So those things you have to wait for the next videos, but this point is very important. And then it does every other things, and the predict method is created. The predict method is going to, the predict module, sorry about that, is going to take the signature. The signature is going to be a simple string. So let us take a look at the usage of this predict. Just a second. I am going to introduce each of the modules, and following that I am also going to introduce the code also. So in that way, you can see the introduction of the module and immediately you can look at the code. I have imported the various supporting libraries like OpenAI and the environmental variables, etc. here. Following that, I have imported the classes that is required for this notebook. You can see that all the modules that I was discussing about, I have already imported it here. I'm going to execute this cell also, so everything gets executed. I am going to create a GPT 3.5 Turbo language model, and I am going to configure it here under settings inside DSPy. So if you don't execute this settings.configure_lm equal to turbo, the DSPy module will not work. So keep this in mind. This particular command syntax is very important. Once that is done, the first thing that you need to do is import rich print. This print helps you to visualize the outputs better. And here comes the predict. So this is what I was talking about. So predict is the module that we introduced a couple of seconds back, and this is the string that I was talking about. So you give a string called question, and there is a separator here, and there is a output. So answer as JSON. So this is the input and this is the output, and this input and output gets coded into the object, and this instruction is given to the large language model. So this is the prompt basically. And once you give the question, provide me the top 2 countries, then the model is able to execute it and provide the answer. So you can see the signature here. I think I have not imported the print. Let me execute this again. So now the print will be looking good again. And if you execute the response, and it will go and connect with the large language model and get the response, and you'll see that I'm getting the JSON output. And also you can see that I'm clearly asking provide me top 2 countries and their GDP for past 3 years, and it is giving me in the JSON format. this is how predict works. It's straightforward, it's simple, and you can control the inputs and outputs by using a simple string. You can actually make it a little more complex by using signature class-based signatures. I'll be using them as I go down into the chain of thought. Now, this is about the predict module, the most basic and the simplest of all the modules. Next is chain of thought. In case of chain of thought, again, it is a Python class, and this is the important point: default rational type. The default rational type reasoning. Let me think step by step in order to produce the last key. So this particular prompt is what you will give to the large language model if you want it to think step by step. And this is coded into the chain of thought class. And whenever you are going to instantiate this object, this what is this called? The prompt gets coded into it. You don't need to type this. That is called as abstraction, and that is the benefit of DSPy. And that is all you need to understand in case of chain of thought, and it will start doing the work. It will start doing the magic. One difference is that chain of thought will also provide something called as rational. So let me go to the code right now. So here you are seeing the chain of thought class being called with a string, which is very similar to what we did in case of the predict. So the string has not changed. As I told you that the string is going to be same, but internally when you call chain of thought, the prompt is going to be modified, and you don't need to do anything. It will be done by the chain of thought object. So let me execute this, and if I use this COT_QA and ask the question is the same question that I am asking here: provide me top 2 countries and their GDP. The question is still the same, and I'm going to execute that. And here I'm going to get not just one answer, I'm going to get multiple answers, because I've asked n equal to 2. So meaning 2 completions will be provided, and there is going to be a bit of creativity here because I have given temperature as 0.7. And let me look at the output. You can see that the outputs differ in the structure, in the output values, and how the output is, how good the output is. All these things are different, right? The point I wanted to make is that you have still worked with the very simple string. There is no unwanted English involved here. You are directly asking for the input. I mean, you are directly telling this is the input and this is the output. You might actually think, okay, how well we can control these things. Why not, give a very clear way of, giving English instructions to the large language model? But one of the downside of that is, if your instructions, you make it as detailed as possible, but if it doesn't work, you will really don't know why it did not work. You might actually think, okay, you did not give the instruction properly. But what if the model itself is not working for all kinds of instructions? You will have to spend a lot of time. When you're going to use these modules, you will see down in the couple of videos that is going to be explained in next series, that you can automate this process. But for that, you have to understand what is going on in these modules. Now, I have executed these right now, and I can do one thing. I can use something called as inspect history on the language model object. And if you execute that, you will see the history of calls that I have made to the OpenAI. You can see the first call that I have made is using the predict, where I have just given the fields question and the answer JSON. The question and answer JSON is prompted like this. As I told you, this is a template that is automatically created. This prompt was not written by me. It is generated by the predict class. So you see the output gets created here. After that, let me make this a scrollable. Next comes, so this is the output of predict. So this is done. And this is the next call. In the next call, still it is same, given the field question and produce the fields answer JSON. And here there is an additional step. So here there is something called as reasoning. Let's think step by step in order to produce the answer as JSON. So this entire process has been done automatically. So if I say instead of answer as JSON, if I say answer as dictionary or answer as some other term, then that will get updated here. and the inputs and outputs are templated here, and then you get the output. So you see that the prompts that the chain of thought, the predict creates, are automated completely. You don't need to type these things, and all you need to do is give this particular string. That's it. Let us now move to the next module. Coming to the chain of thought with hint. Chain of thought with hint is very similar to chain of thought. Only thing is that we are going to give an additional variable called as hint. You can see that here, and this hint is linked with the prompt, and that is also done automatically through this calling of chain of thought with hint. Rest of the things are same as chain of thought module. Only thing is that this hint is going to be provided by the user at the time of execution. So you'll see how this works. And most important point is that you are not writing the prompts. The prompts are already coded into the classes, and you are just calling the classes and creating objects using that. All the objects will contain these prompts. Let us go to the code. So here we are. In this case, I am having an additional hint that I am providing. I am creating the chain of thought with hint object, that is COTH_QA. The string is still the same. I have not modified it. I am telling the input is question, the output is answer as JSON, and then I am giving an additional step called as hint, and then I get the output. As you can see here, the output is coming out as a rational and answer as JSON, and you can see that in case of predict, you will get only the answer as JSON, but in case of chain of thought with hint and without hint, you will get this rational. And this rational is how the chain of thought, the model decides, okay, whether a particular answer is correct or wrong. This chain of thought can be used effectively with the retriever, that is the VectorStore retrievers, and it helps a lot. Let us go back to the next module. Next is multi-chain comparison. This module has something different in the store. It starts with a simple signature, but here you will see something called as m equal to 3. So the m here is not 3 models, it's actually 3 students. What happens is, internally we create 3 predict objects, or m number of predict objects, and we tell these predict objects to create or generate outputs, and then we ask the main model to do accurate reasoning. And once that accurate reasoning process starts, this particular prompt is told, thank you everyone, let us know holistically, and then the correct reasoning is provided and the final answer is decided. If you look at when I explain this thing, it looks as if the model can do some kind of decision making. It can actually spawn some students internally, or real people internally, but actually it's not spawning any people internally. It's just creating predict objects. If you have seen how the predict object works in the earlier part of this video, you will know that it is basically a signature given to a large language model, and that large language model is going to generate output. That output is going to be checked and reasoned by a top model at the last step. So that is how multi-chain works. It is better to see this in action. So let us go to the code. Here we are going to use a multi-chain comparison. What we are going to do is, we are going to send a couple of rationals to the model, or to the module, not the model. We are going to send these prediction objects to multi-chain comparison module, and the signature of that multi-chain module is still very simple: question, input, answer, output. Here the rational is the input and answer is different. For 3 rationals we have different answers. So I recall during the clear days, the sky often appears this color, that is answer blue. Based on common knowledge, I believe the sky is typically seen as this color, green. I mean, what is the typical knowledge? It's wrong anyway, but there is some output that says that the sky can be green also. From images and depiction in media, the sky is frequently represented with this hue, that is blue. So the rationale that you see here may not be logical, it may not be factual, but these things can still be written, correct? So we are going to give these inputs to the multi-chain comparison as completions, and we are going to ask what is the color of the sky, and this question is posted to the multi-chain comparison, and internally these rationales are going to be given to the students, and the students, that is the predict objects that I spoke about when I introduced multi-chain, they are going to check it, and finally the output is going to be provided. So the final model, the correct reasoning, by considering the scientific knowledge and the observation, the color of sky is predominantly blue due to Rayleigh scattering. So this is very scientific in nature. That's what the model finally replies when you are going to use multi-pred comparison. And finally the answer is the color of sky is blue. The answer is correct. So you can see that whenever you are going to work with a very complex topic which requires a lot of thinking, if you have a product that you're going to build, then think about using multi-chain comparison. But you need to still research a lot with multi-chain with lots of data and see how the output functions. Regarding the evaluation of the prompts, these modules, it can be done very easily once you understand to use the metrics and the data objects that I will be discussing in the next video. Moving forward, before we continue, I want you to take a look at this particular output. So let me complete this execution. So let me execute this, and once I execute that, you will see the final response, and this final response, after that is completed, I want you guys to take a look at the inspection of the history. So let us inspect the history. Turbo.inspect history n equal to 5. So I want to check the history from the beginning. So let us scroll down. So if you see at the end, this is the prompt that the multi-chain object creates, the multi-chain comparison object creates. Given the fields question and answer, follow the following format. So the question, student attempt 1, so reasoning attempt, student attempt 2, reasoning attempt, student attempt 3, reasoning attempt. So 3 student attempts are created, and finally the accurate reasoning is generated and the answer is provided. So that is how the question that we provide is sent to various student attempts, that is the predict objects, and the accurate reasoning is executed. So by looking at the when you look at the simplistic looking single line invocation of multi-chain comparison with this input and output, you cannot actually believe that how such a prompt can be created. I mean, when you look at the output here and look at the various the complexity of the prompt, one might actually think, okay, it has to be written by the human, but it's not. It is actually written programmatically using the class object that I showed at the beginning of this part, beginning of multi-chain comparison explanation. This is what I was talking about, that prompting has been completely made into programming. Let us continue with the next module. Next module is ProgramOfThought. It's very similar to ChainOfThought, but instead of actually thinking, the ProgramOfThought or POT or POT is going to create code. It is going to create code, it is going to execute code, and it is going to output code, output answer. So you can see the 3 steps. The generate mode serves an initial generation of Python code. The regenerate mode serves as refining generation of Python code. The answer mode serves to execute the last stored generate code. So this is a very important point. It executes the last stored generated code. That's what you guys have to understand. That's it. You don't need to really go into this ProgramOfThought code. In fact, even the documentation doesn't provide a full information on ProgramOfThought code. Okay, even this particular syntax that you see attach here, it doesn't work. So for some reason, this actually throws an error. All you need to do is use a simple signature the signature that you see here, and you send it to ProgramOfThought, and you can ask the question, and you can send that question to the ProgramOfThought object, and you'll get the output. So let me actually execute it right here. See, you might be thinking this is one of the most complex looking or sounding module, and I'm not actually diving deep into it because it's actually complex. You don't need to understand the complexity because it has been already abstracted away by the coders, by the Python object-oriented programming. All you need to know is that how the code creates the prompts. So that you can actually see. So let me execute this. It will execute, and after that executes, you will see that the answer is 12 apples. So Sarah has 5 apples. She buys 7 more apples from the store. How many apples she has? You have to just add it, right? You can ask the regular model also, it will work, but here it's a simple example. But you'll see that if you go here, and if you now look at the turbo inspect history, this inspect history is one of the most important method that I have come across. Let me actually say n equal to 6 right now, because this is almost 6 prompts that I have done right now. And if I go down and if I make it a scrollable element, and here is the output that you see, and you can see given the final code question, just a minute, we need to go scroll up further. So it's not a single call that has been executed. So multiple calls have been executed by the last execution that I made with the ProgramOfThought. So you'll be given question and you'll be responding with the generate code. So this is the first execution that is being done, the generating executable Python code. And if you scroll down, you'll see that the Python code is executed here, created here. It's not executed, it is just created. So the inputs and the total apples and the output is all written in Python. So it's the code here. You scroll down, given the final code. So this is the final code, the question, final generated code, code output, provide the final answer. So the final generated code is executed below. So if you scroll down, the output of the previously generated Python code, if you scroll down, it is executed here, and the code output is given as 12, and the answer has been updated as Sarah has now 12 apples. That is actually using large language models completely for generating the answer. And it might look simple, right? It's not a very complex question, or it's not a very complex calculation. But the point that I wanted to make here is that the large language model acts as a Python interpreter. It's acting as a basic calculator also. Even then, it's still doing that, right? And you're instructing it. The model has been already trained for these kinds of stuff. This is what you guys have to understand. This entire prompt that you're seeing here, it's not written by hand. It's written by the code. You can actually modify the code. There are ways to modify this. You can manually, or you can do it automatically also. That we will look into the next couple of videos, but it can be modified. So that's about the ProgramOfThought. Let's go to the next module. The next module is React module. React module is going to work with a couple of tools. The React module can directly work with the retrieval options. It can work with various kinds of Python functions. And here, the example that you see at the bottom will be more with the VectorStore retrieval. So I'm not diving into the React module that deep. Next, we are going to go into the retrieve module. In the retrieve module is basically a VectorStore retriever class. So you create this retriever object, and you have to connect the retriever object with the language model that is already connected with the VectorStore. This is the key point. I was initially not able to understand this. So this is the class. They have not given the complete implementation here, so just don't worry about that. This is the query. When was the first FIFA World Cup held? And initially I thought, okay, let me create a retrieve object like this, and if I send it to the query, I will get the answer. If you execute this, you will actually end up with errors. So how we have to execute it correctly? So let us scroll down. We have to first of all use ColBERT v2. So this is one of the fastest, they are claiming it, fastest VectorStore search code available. You can use this ColBERT v2, and you can connect to this particular link. You will be able to query the Wiki 17 abstracts. So Once you do that particular connectivity, then you need to send that retrieval module. So this ColBERT wiki rm is a retrieval module that you need to send into the configure settings.configure along with the large language model. So this is the key step. If you don't do this, then the retrieve object will not work. So after you do that, here I am showing the React object. So let me close this. You need to create the retrieve object. So retrieve k equal to 2 means 2 passages will be retrieved. And now when you execute, when was the first World Cup, FIFA World Cup was held, you'll see that it gives the extraction from the wiki data. Just give me a second. I think I did not execute this. Just a minute. Let me execute this. That's done. And let me execute this right now. I believe, yeah, you see there are two outputs. Okay, this is the passage output that has been extracted from the this particular vector store. So you see the link here, but the vector store is actually hosted in this particular IP address. Next, what we need to do is we need to send the raw retrieval into the retrieve object. So in order to do that, you have to execute this particular cell and you will get the output. After you do the raw retrieval, you will get the passages, and this passages has to be sent through the predict object. So you see there are two steps. So first you need to retrieve. So here the retrieval actually works like this. I have actually shown it for you to look at how the retrieval works. But in when you are going to implement it, you will just implement it like this. You will not actually look at the outputs, right? You will just implement retrieve query, and that raw retrievals you will send it to the predict object that you have created like this. So question context. In the context, you are going to say raw retrieval passages. So that is how you will send it. So the signature is question and context. So these are all both inputs, and this is the output. So that's how it works. And the output, if you execute it, it will actually give the answer. The answer is the first World Cup was held in 1930. So that's the answer that it has been able to extract from the wiki abstracts, and this is the output. And we are not going to stop there, right? We are going to see how the actual model worked. So for that, you are going to do turbo inspect history n equal to 8. Let us make it a little bit bigger numbers because there were lots of calls that has been made to this particular model. So you can see that here that given the fields context, question context produce the answer. So you give the question, you give the context, the passages that you've sent, the context is actually placed here, and then the question is provided, and also the context is again placed here, and the answer is given. So what is this context? So this particular context that you have sent it also gets returned by the object. So let me go up. If I just a second, sorry about that. So if I go here and if I take a look at here itself, you can take a look at it. So you can see that there is a context available here from here to here. So this is the context that is given as an output when you execute this particular command. So the context also comes out along with the output, so along with the answer. So that's one of the points that I wanted to highlight. Similarly, when you are going to look at the ChainOfThought or ProgramOfThought also, you can get additional data. You will see additional information that is sent through this module by the large language model. Now you might be wondering that are we going to look at any other modules? Actually, you can actually look at the other modules, the majority, the React, and also the other modules that I have introduced. Just a second. So these are the various modules that I have introduced. So you saw the modules, the code, and following that the implementation of the code with the walkthrough. You have seen that. You have seen predict, ChainOfThought, ProgramOfThought, multi-chain comparison, retrieve. But majority and React we did not delve into that deeply. Most of the time you will be able to execute stuff using these modules that I already introduced. In fact, the tutorials that you will find in the internet and also in the various other videos, they will be looking into these things only. The way majority and the React modules work is very similar to from the implementation aspect. It's very similar to how the rest of the modules work, but the internal prompts will be different. So keep that in mind. I am telling that React and majority will work similar to the modules, but the prompts of these modules will be different. So I want you guys to explore that. So in this video, we have tried to work with not just work with the modules. We have tried to understand the prompts that are built into the modules and how prompt building or prompt engineering has been completely abstracted from the user, and just by creating simple Python classes and calling them as objects, you can modify the behavior of the large language models. In the next video, so in the next video, we will be diving into data, and also we'll be diving into metrics, where you will understand how we can evaluate the outputs from the models. So stay tuned for that video. And the data and the metrics video is very much linked with the modules that you have seen right now. So ensure that you watch this video, and then once you understand and execute this code, it's pretty simple code. You may not need to type a lot of stuff. All you need to try working with this, changing the questions, changing the vector store. If you have a different vector store, you can try to send it through the DSPy modules. You can try that out. If you have any questions, you can ask me in the comments. I'll be glad to help you out. Apart from that, I believe that you have seen an overall idea of the modules and how the prompts are getting abstracted. So till the next video, try to practice this, the code that is already available here. Review the module implementations if you like to understand the prompts a little more deeply. And yep, practice. See you guys. Have a great time.